Okay, next we got to find the time of LAN. Before we even get the latitude of LAN, we need its time, obviously. So the way we're going to start with this is we're going to find the time of MerPass, and we're going to set a DR position for then. So here, there we go. Here's our November 3rd and 4th page. And if we look down here, we're actually, to be clear, we're finally on November 4th in GMT time because it's been a few more hours. And meridional passage happens at 11:44. So we're going to write MerPass 11:44. Before going any further, before we start calculating how far apart we're going to be from our central meridian, we got to get a DR position for 11:44. So if here's our 10:14 DR, and we no longer have a fix that we're really working off of, we're just going to roll with 10:14. We have to find how long until 11:44. Well, that's an hour and a half. Yeah, because 10 to 11 will be an hour, or 10:14 to 11:14 is an hour, and then to 11:44 is another half an hour. So we've got 90 minutes we're working with here. Times 15 divided by 60 gets us 22.5 miles. So we're going to measure out 22.5, put it right there. There's our 11:44 DR. And remember, because this is an LAN problem, our latitude of our DR does not matter. All we need is our longitude. So we're just going to find what our longitude is at 11:44 based on our DR position. And you're going to see we got what appears to be 161 degrees, 15 minutes. So we're going to write here 161 degrees, 15.0 minutes east. All right. We'll set this up just like usual. Zone description, minus 11. That's going to give us a central meridian of, let's see, 11 times 15. I don't remember what it was. It was 165. So our central meridian is 165 degrees east. So now we're going to compare 165 degrees, which is 164 degrees, 60 minutes east, to 161 degrees, 15.0 minutes east. Get our difference. It's going to come out to 45 minutes and 3 degrees. 3 degrees, 45 minutes is equivalent to 3.75 degrees. So we're 3.75 degrees away from our central meridian. 3.75 times 4, times 4 is going to get us 0.75 times 4, 15 total minutes. So we're 15 minutes different from MerPass. Remember, we are west of our central meridian. Our central meridian is 165, we're 161. So this is 15 minutes later. So we're going to add that to 11:44, and we're going to get 11:59. So LAN happens at 11:59. Now that we have that information, we could, in practical situations, we would then be able to, set up at 11:55 or something and get ready. And right at 11:59, we could take a shot of the sun and get when it's at LAN. By the way, this reminded me, I've seen it happen before where teachers will pick a day's work problem that passes over into a new time zone where you went from minus 11 time to minus 10 time. This is done to trick you, because if you do this problem again, you would find, we're in minus 10 time, and you do your corrections differently. Remember, you don't change time zones, or you don't change your clocks during the day. You change your clocks at night. So even if you pass into a new time zone, if you began the day at minus 11 time, you're staying with minus 11 time for that whole day. So you wouldn't need to redo this if we were to pass into a new time zone. That didn't happen here, but I did want to make note of it because it's messed people up before. Okay, Now though, now that we've gotten our time of LAN and we'll now move on to the lat by LAN. And so at 11:59, we were sitting out there. We got a shot of the sun, and we had an HS of 56 degrees, 56.4 minutes. So now we got to find our latitude by LAN. Remember, the first thing we got to do is convert this to HO. So IE, dip, HA, main, HO. 0.3 on, minus 7.2. I know it's tedious, but it's because it's necessary to do this every single time. So we're going to do 56.4 minus 0.3 minus 7.2. Gets us 48.9 minutes, 56 degrees. We're going to come to the front here. 56, so we got LAN off of the lower limb of the sun, and still October to March. 56 would get us plus 15.6 minutes. So we do positive 15.6 here. So that is 57 degrees, 04.5 minutes is our HO. Now that we have HO, we can start the process for LAN. Remember, the first steps are just we get our zenith distance. So we do 90 degrees minus our HO to get us our ZD. So 90 degrees is 89 degrees, 60 minutes. Our HO is 57 degrees, 04.5, meaning our zenith distance, just the complement to HO, is 55.5 minutes, and then 89 minus 57 is 32. So 32 degrees, 55.5. Now, we need our declination. I forgot about that. So we're gonna find our declination now. So we're gonna do dec, D, dec. Okay. 4th of November, and that's why we needed our time as well. There. So November 4th, 11:59 local time. But remember, local time is what's local time? We have to do minus 11. So 11:59 minus 11 gets us 00:59. So it's midnight on the 4th, and that gives us a declination of south 15 degrees, 16.7 minutes. South 15 degrees, 16.7, minutes. Our plus D is still 0.8, positive. So we're gonna come to minutes and seconds, and we're looking for 59 minutes here, because it's at 11:59. Or it's at 12:59 local time. And at 59 degrees of increments, we have 0.8 is equal to 0.8. I mean, that's not surprising. Yeah. So we're going to add 0.8 here, and we get south 15 degrees, 17.0 minutes. So we're going to bring that down, 15 degrees, 17.0 minutes. All right. Now we have our zenith distance and our declination. What we need to do here, though, is we need to figure out how we're actually applying these together, because remember, we don't always remember what relationship we have with the sun right now. So we're going to draw the diagram. We're in the north, so we're right. Yeah, we're right. We're right here. The sun is in the south, so it's here. So here's our latitude. Here's our zenith distance. And here's our declination. Meaning in this situation, latitude is equal to zenith distance minus declination. So we're going to subtract the two. So we're going to write it nice and big here. We're going to subtract declination from zenith distance, and we get 55 36.5 minus 17 is 38.5 minutes. And then 32 minus 17 is 32 minus 15. 32 minus 15 is 17. So you can see right there, the latitude by LAN is 17 degrees, 38.5 minutes north. And if we come to our chart, or our plotting sheet, you can see that's really close to our time of LAN. So then in the next video, we're going to actually plot that down, and we're going to advance our times.